Welcome to the presentation of Ginko Garden Bot, a smart way to take care of your plants. Ginko Garden Bot is a platform developed following the microservices approach. In this slide, it's possible to see all the different entities that cooperate together to offer multiple functionalities to the end user. The main service is the service catalog, which keeps track of all the service active and update continuously. Each service active must then continuously put requests to the service catalog, specifying which are the endpoints of the service itself. In this way, service discovery is made possible sending a GET request to the service catalog. The device catalog acts in the same way, and the device connector is responsible for registering the active devices. The FinSpeak adapter discovers the device is active from the device catalog and registers to the related topics. When it receives data, it sends them through a GET request to the FinSpeak platform, which is used as a database. The data analysis service can manipulate the data and expose methods to get average daily values. Moreover, it keeps updating a list of critical values for each plant when specific thresholds are reached. Finally, Freeboard and the Telegram bot are the instrument given to the user to monitor their plant's state and take actions. The sensors and the actuators available for each plant are the temperature and humidity sensor, the relay dedicated to the light, and the relay dedicated to the pump, which are all connected to Arduino. All scripts run on the Raspberry Pi that communicates with Arduino through an USB cable, and is connected to Internet thanks to the Wi-Fi module. In order to communicate, both RESTful approach and the MQTT protocol are exploited. The FinSpeak platform exposes temperature, humidity, pump status, and light status, which are stored in a different channel for each plant. The device connector enables pump and light activation through a set of GET requests. The data analysis service provides average temperature and humidity and a critical condition list, where critical temperature and humidity values are stored if detected. The catalog service exposes a list of services and devices active together with the necessary endpoints to enable discovery and communication between the services. A publish-subscribe interface enables the continuous flow of data from the device connector to the FinSpeak adapter, as previously said. Telegram and Freeboard are the user instruments to monitor plants. Multiple users can access freely the Telegram bot. The platform is developed to be used by a group of people, like a family or greenhouse workers, that want to take care of the same plants. Access to plants resources is free, but messages are sent from the Telegram bot to make all the users aware when an action takes place, for example, the activation of a light. Moreover, alert messages are sent when critical values are discovered. This is possible thanks to the Telegram bot that sends continuously GET requests to the data analysis services to check if any critical values been found. For what concerns the dashboard, in the next slide it's shown a sample of what the user can see using its browser. The dashboard is automatically created when a new plant or sensor is added and keeps track of multiple information like last value sensed, historical charts, and last activation of pump and lights. The dashboard creator is automatically started by the Freeboard service each time a new plant or new sensors are added, and this script, creates a JSON file which is used by Freeboard to understand how the dashboard is organized. Ginko Garden Bot is made to be almost ready when the user receives the product, except for the hardware setup, the user just have to modify a configuration file before running the scripts on the Raspberry Pi. In the next slide, there is a sample of the configuration file. As you can see, under Sensors keyword, there is a list of all the plants that can be updated up to 4 plants. If the user decides to extend the number of plants, he can purchase a full version of TeamSpeak and specify the ID API key on the bottom of the configuration file. For each plant, the user must specify the name and the list of sensors available. If a sensor is available, its unique ID and the Arduino pin to which it is connected must be specified. If a sensor is missing, the user just has to put null instead of the previous information. It is also possible to define which port to use for each service and the broker address and port. Finally, if a new bot is created by the user, the corresponding token must be changed in the configuration file. As previously mentioned, the device connector is the service responsible of dealing with data coming from the sensors. However, at the same time, it must register the active devices to the device catalog. This is made possible exploiting the multi-threading module authored by Python. Two threads are associated to each device. The first sends in a loop a put request to the device catalog, while the second one keeps track of the device status, connected or disconnected. If the device is disconnected, the second thread clears the associated event flag, and the first thread is put in the waiting state. If the device is connected again, the event flag is set, and the first thread starts running again, registering the device to the device catalog. This increases the fault tolerance of the platform and prevents the user from restarting all the services if a disconnection occurs. In order to increase the fault tolerance not only from an hardware point of view but also from the software side, the try except statement has been used each time a request is sent to another service. This makes possible to have the services running even if one of them crashes. However, some of their functionalities associated with the crashed service will be not available until that service starts running again. Moreover, Ginko Garden Bot can be moved to different networks without effort from the user, since the IP address to which the Raspberry Pi is connected is automatically retrieved.
Hello, today I will demonstrate our project and explain some properties of it. At left side on laptop you are seeing our Raspberry Pi screen, and at right side you are seeing our hardware component. First of all, I want to start with explaining our hardware components. We have one Raspberry Pi and Arduino Uno, which is connected to each other and they are able to communicate in both directions. Later on we have two relay connected to Arduino as an input side. At output side of relay we have connected pump and light. And last hardware component of us is DHT11 sensor, which is collecting humidity and temperature information from the environment. Now I will start all the software components. Later on I will demonstrate the properties of our project with Telegram bot. So I launched all the software components. Now I will continue to demonstrate the ability of our project with Telegram bot. In this part you will see the Telegram on the screen as well. First time when you connect to the Telegram bot, you will see this screen and you must start. After that we are able to collect all the information from environment. I will start from beginning. When we ask temperature, our system asking which plant you want to learn. We want to collect the information. So we did our project in a scalable way, which means you can have more than one plant at the same system. In our case, the plant 1 is just right in front of you, so I will collect the information from our plant. I will go on with humidity as well. And status functions. So now I will turn the pump on, and you can observe the difference from the liquid level of water. So it activates a pump for a time duration for security reasons, if in case of you forget to turn off or something like that, it has time limit to turn it on. So now I will switch on the light. And in this part I want to show something extra. More than one user can connect to system, and just right now you saw the light is turned on, and in my screen it says Alper has switched the light of plant 1, which means more than one user able to connect the system, and they can do a change on system at the same time. That's why the light is turned on. Now I will go on with service list. Here it shows our services, and the last properties is device list. So here we can see our component one by one, which is connected to system. So in device list we are able to detect in case of any problem of hardware connection or something goes wrong in system. So I will just plug it off the connection of light. To be able to more visible, first I want to switch the light on, then I will disconnect it. So I will switch on the light right now. So it's turned on, and I will disconnect the connection. Now I will check the device list again. It takes some time to detect. So now as you can see, there is no light connected to system, and we are able to detect it. So I will plug it back and check the device list again. So now the light is added our device list. Last thing I want to show, we have also freeboard to check able to follow information from online. Here you can see the freeboard of our system. That's all for demonstration.